13.8 billion years ago, the universe started with the Big Bang. Energy transformed into matter and antimatter. But what happened next? According to discoveries made by Albert Einstein and other physicists, the Big Bang must have produced equal amounts of matter and antimatter. Yet the stars and galaxies we see across the universe are all made of matter. What happened? Why did matter win over antimatter? A new experiment aims to find out whether tiny particles called neutrinos might be the reason. Neutrinos are the most abundant matter particles in the universe. Trillions pass through us and everything else in the universe every second. They are produced in huge quantities in our sun and other stars, and in smaller quantities inside our Earth. Even bananas emit neutrinos. Scientists can produce neutrinos and antineutrinos with particle accelerators and study their properties in great detail. The Deep Underground Neutrino Experiment, DUNE, will test whether neutrinos and their antimatter counterparts behave differently. The experiment will be housed in the Long Baseline Neutrino Facility and use a particle accelerator at the Department of Energy's Fermilab. It will create the intense beam of particles that travel 1,300 kilometers through the Earth to the Sanford Underground Research Facility. DUNE scientists will build enormous, super-sensitive particle detectors while advancing state-of-the-art technologies. The detectors, located 1.5 kilometers underground, will catch neutrinos and antineutrinos as they arrive at Sanford Lab. The differences in the particles' behavior during their 4-millisecond trip from Illinois to South Dakota will tell scientists whether neutrinos could be the reason that the universe is made of matter. But DUNE can discover even more. If a star explodes in our Milky Way galaxy, the DUNE detectors will be able to see neutrinos from that explosion here on Earth. That will allow scientists to watch how the supernova leads to the formation of a neutron star, and possibly a black hole. The DUNE detectors can even look for particle tracks from proton decay. Many theoretical models predict protons are unstable, but fortunately for us, the average lifetime of a proton is very long, more than 100,000 billion years. However, a proton could decay at any given moment. If scientists observe it, they'll narrow down their models, moving closer to Einstein's dream of finding a unified theory of matter and energy. From neutrinos to black holes to proton decay, the discoveries made by the International DUNE collaboration will transform our understanding of the universe.